Ladies and gentlemen, please welcome Dr. Sean Randolph, Senior Director of the Bay Area Council Economic Institute.
Well, good afternoon, everybody, and welcome. It's a real pleasure to be able to introduce our next speaker. I think we're in for something very special, and for several reasons. So, our economy in this region is led by technology. Now, as you saw from the slide that Michael put up a bit earlier, we're actually a remarkably diverse economy. We're not dependent on any one sector. I think everybody knows that we're identified with technology, and generally if technology is doing well, the region is doing well, and if technology is in the tank, the region is in the tank. And one of the reasons we do so well so often is because of our research base. We have here in the Bay Area what's probably the deepest, strongest, most sophisticated base for research anywhere in the world, certainly in the US. At least we like to think so. Our speaker is from Boston, so I probably shouldn't go further down that road. But it is an extraordinary resource that helps make the Bay Area's economy what it is. And our ability across many disciplines, from tech to life sciences to clean tech and nanotechnology and on, our ability to bring that research to bear to address major economic and social challenges is also a hallmark of this region. It's what we're identified with, it's what we're good at, it's why we're helping right now to transform the world and industries throughout it. And it's what makes this area such an exciting place for so many of us who live here and that attracts so many brilliant people from around the world to be part of our economy. Now, PARC, a Xerox company, Palo Alto Research Center, has been a core player in that process for decades. It was one of the key founding research institutes of Silicon Valley. It helped to make Silicon Valley what it is today. And to this moment, it continues to generate cutting-edge, transformative technologies in areas that are driving change in energy, smart cities, manufacturing, and many, many other disciplines. Now, it matters not just in the big picture, but it matters for us here in the Bay Area as well, as we're facing increasingly complex challenges. One of the report covers that Micah put up earlier was a report we produced last year called 21st Century Infrastructure, Keeping California Connected, Powered, and Competitive. And what it is, it focused on challenges in two key sectors. One was communications, and the other was energy. The communications challenges stem from something we heard about a little bit earlier today, the accelerated digitization of the economy, how everything is connected, people and mobile devices and increasingly machines through the Internet of Things, straining our broadband infrastructure, but literally transforming every industry day by day. The energy challenges are stemming from our success as a state in bringing on more and more renewable power that, unlike power that was once generated at a central generating plant going one direction, now it's coming from every direction. And it's coming from rooftop solar, it's coming from distributed generation, and we need a more flexible, smarter grid, better ways to manage that, and that also relates to information technology. And so this brings us to the theme of our speaker today, which is energy democratization. How we address these issues are really going to be central to how we grow as a region. And our speaker is going to be sharing a perspective, especially on the issues in energy, coming to us from the world of advanced technology research. So Sophie Vandebroek is the Chief Technology Officer for Xerox Corporation, and she's president of the Xerox Innovation Group. She was born in Belgium. She earned a master's degree in electrical mechanical engineering, later served her PhD in this country from Cornell. Dr. Vandebroek is responsible for Xerox Global Research Labs, which has a mission to create high-impact innovations and drive the bottom line and revenue growth. Now, the labs are located everywhere. They're in Europe, they're in Asia, they're in Canada, and they're also right here in the Bay Area at PARC, the Palo Alto Research Center in Silicon Valley, that provides custom R&D services, serving both clients as well as Xerox company itself. She's been at the company for about 14 years. In previous roles, she served as the company's chief engineer, vice president of the Xerox Engineering Center, technical advisor to Xerox chief operating officer, and director of the Xerox Research Center in Canada. Dr. Vandebroek, very distinguished background, is a fellow at the Institute of Electrical and Electronics Engineering. She's a Fulbright fellow, a fellow of the Belgian American Educational Foundation. She has 14 US patents to her name, received many awards from Monsanto, Belgian National Science Foundation. I could go on and on. She was inducted, which we think is just fantastic, into the Women in Technology International Hall of Fame, elected into the Royal Flemish Academy of Arts and Science, and is an advisor to the Dean of the Engineering School at MIT. So we obviously have an extraordinarily accomplished guest speaker. I think, again, you're in for a real treat and some real insight into what's driving change through the democratization of energy. So please welcome our speaker, Dr. Sophie Vandebroek.
Thank you, Sean. Thank you very much. Excellent. So our vision of democratizing energy, once we achieve it, it will really accelerate progress towards a more livable world. What do I mean with democratization of energy? What we mean is to empower each and every one of us, each individual, to truly take control over her or his energy footprint. A lot of things need to happen in order to make it a reality. One of those items is significant technology advances. And the good thing is that one of the major technology trends today that is happening at the moment is the emergence of the Internet of Everything. And as you will see, that will really help achieve this vision. You can say, why is the CTO of Xerox talking about energy? Well, in addition to really have a focus on creating a sustainable enterprise ourselves, we work with clients all over the world to help them print less, to help them manage a more energy efficient office. In addition, in our transportation business, we work with cities around the globe to process many of the transactions related to public transport, for example, 37 billion public transport, payment transactions, buses, trains, we manage parking, we help with toll, easy pass type transactions, etc. And all that information gives at the fingertips of city officials the power to create more sustainable cities by optimizing the flow of citizens through the city. And finally, we work with hospitals all over the world, and mostly in the US in this situation, to help them manage and make the hospital more effective and efficient. And as we all know, when your enterprise is more effective and efficient, you use less energy. Coming back to democratization of energy, the best way that I can explain the principle is by looking what happened to the information technology industry of the last half century. So about 50 or more, 60 years ago, if you're an accountant or an engineer and you wanted to solve a really difficult problem, you had to work through intermediaries that then worked with the big centralized computer, those mainframes. You had to work with individuals that knew the machine language and could help you solve your problem. Individuals, and then you got the answer back. You did not have any control over the centralized systems. When they were upgraded, who bought them? Number one, they were way too expensive, and you were far removed from the centralized computing system. You just got the results. And then, of course, Moore's law happened, right? And a lot of the ideas of the acceleration then to personal computing and beyond came out of the valley, came out of Silicon Valley right here in California. Initially, the personal computing was invented. A lot of the basic technologies came out of our Xerox Palo Alto Research Center at the time. And then personal computing, mobile devices, contextual intelligence, all the way today, as I mentioned, the Internet of Things. And what it has done is really put all of us in control of the information that we need and get access to that very fast. Now, though, for example, today you can Google, I mean, everybody can Google any information that you really need to know. And we own multiple mobile devices, and in the future, multiple of these devices will be all around us. So, and we all know, especially again here at the heart of where a lot of this revolution happened, or the democratization of energy happened, we all know that that led to a significant amount of innovation and wealth creation. Well, we see the same happening, or is going to happen, in the energy sector. Today, when you switch on a light, in most parts of the world, the light will actually go on. But we have no idea where the energy that's being used actually comes from. It is a very centralized system with multiple sources. I've just plotted a few of them here, multiple energy sources. And so we have little choice, and there is also in many parts. I live in Boston, in Massachusetts, and there is basically no competition. I only have one provider I can work with. In addition, we really have no awareness of all the externalities. No matter the energy source, there are side effects of emissions and toxic materials, or disrupting the nature and wildlife, etc. So you can see that there is very little that we know when we take these actions. So the vision of really empowering individuals to take full control over their energy footprints really means that you have personally the choice to trade off cost, quality, environmental impact. And many of us, if we had the knowledge at our fingertips, the data and information at our fingertips, would actually want to be able to have being more empowered related to how we use energy and when and which. So what we see is there are three main areas of technologies that are required to make this vision a reality. Number one, and a lot of work is happening in this area already, is smart devices, right? So consumers become both consumers of energy, but also producers of energy. So it's smart solar, of course there are wind farms, it is smart distributed batteries. So that continuing to evolve these technologies will be very important. Secondly, there is the whole smart infrastructure that will connect these smart devices at the edge and in people's homes and in cities together, so that we then clearly understand, and the data is available. For example, smart sensors in the home, smart thermostats have been used quite for a long time. At one point in my career, I was CTO at Carrier Corporation about 15 years ago, and we were working with Honeywell on Comfort Choice, for example, to allow the utility companies to have control on optimizing the energy demand versus energy that's available at certain times in the day. So in addition, though, for consumers, there is not yet something that's equivalent to a nutrition label. When you go buy food, you have a lot of information about the ingredients in your food, as well as the impact from a calorie and etc. point of view. So what is the equivalent of that in the energy world, right? That as a consumer, you really know the facts about the energy that you will be using. And you can overlay on this smart infrastructure, obviously, the policies and the requirements, and governments and cities and countries can put policies to reduce greenhouse gases overlaid on the smart infrastructure. And then ultimately, we envision a marketplace where the consumers and the producers leveraging all these smart devices and all the intelligence, where it comes together, and that then optimizes energy demand and energy production. And of course, none of us is going to have the time to manage that on a daily basis. So there will be smart, intelligent agents that will act on our behalf, that will start to understand what our needs are and what our wants are, and then will optimize this whole energy infrastructure and marketplace. These three pillars, or these three areas, are in fact very similar to what is happening in the Internet of Things, or the Internet of Everything. I see these three pillars in the Internet of Everything. One is indeed all the smart devices, not only energy devices, but across our homes, our cities, our work. There are multiple things that are starting to be connected to the network and really capturing a lot of information. whether it's wearables that are being used in the healthcare sector, or again, at homes, and of course, our multifunction devices have been connected to the internet for well over 15 years at the moment. All of that is being then linked together through smart infrastructure, information infrastructure, transportation infrastructure, and energy infrastructure. And then ultimately, it's the number 3 is real-time insights that are created by looking at all this sensing data, analyzing it, and then providing personalized services back to the individual or to the businesses as required. So what I will do today is leveraging these key areas to explain some deep dives into some energy-related projects that we are doing at our Palo Alto Research Center, PARC. PARC has been incorporated. The difference between PARC now and in the 70s is PARC has been incorporated as a business. It's PARC Inc. And PARC provides innovative services, R&D, research and development services, not only to Xerox, about half the revenue at PARC comes from services to Xerox, but also to many other commercial clients, government, equity in startups, IP licensing, etc. And so at PARC, we have a lot of capabilities and competencies. It's not a surprise that a lot of the capabilities are aligned with these 3 areas that I described earlier. There is a strong capability in creating smart devices, everything from the materials to the systems, to, of course, computer science and software required. Number 2, we are working in the area. As you know, original Ethernet standards were created in collaboration with others, but also at PARC. And so we are working now on, for example, creating the next information network standard called information-centric networking or content-centric networking. But there's much more capabilities in that area, as well as a significant amount of artificial intelligence, deep learning, etc., capabilities to create these real-time insights. And so leveraging these capabilities, about a decade ago, Scott Elrod, who is a laboratory director at PARC and with us today, started a program around energy. And so here are a subset of the projects in the program that we are working on today. So you can see different subsections. One is about energy generation related to solar, etc. At the fundamental level, creating more and better, helping with energy generation. It's about energy storage. It's about energy efficiency, like optimization for data centers. And it's about transportation. I will illustrate each of these 3 areas with one project. Get to some of the science here today. And these are 3 projects that are all funded by the Department of Energy. In fact, ARPA-E, the Advanced Research Projects Agency in Energy. And PARC is the single largest provider or institution that does research for ARPA-E. And so I'm just going to select 3 of them. The first one on smart device, smart infrastructure, real-time systems. I will go each 3 of them. The first one addresses a really large problem that we're painfully aware of in California, like the gas leak in Porter Ranch. Before the gas leak was closed, 90,000 metric tons of methane gas got released in the atmosphere. And that is, and methane is about it lasts longer in the atmosphere, but it's about 84 times worse from a greenhouse gas emission versus carbon over a 20-year period. So it's a big deal. And there are also lots of legislation happening, as you might have heard last week. The EPA's regulations around being able to minimize leakages around oil wells and gas wells was introduced. The goal is to reduce overall leakage by 45%, and that will in fact also create wealth, because that 45% that's not going to the atmosphere is actually used effectively and can be sold. And so ARPA-E, so the Department of Energy, also saw this as a very big problem, because yes, Porter Square, the gas leak was, of course, Porter Ranch was a very big disaster, but little leaks happen everywhere all the time. And so the goal for the DOE program was to come up with, as I listed there, distributed methane leak detection for gas wells that would cost less than $3,000 a year to operate, so that leaks can very quickly and early be detected. And so what we did at Xerox, or at PARC Inc., the team was able to propose a project to address this big challenge by leveraging over 15 years of printed electronic leadership the researchers that have been working on print electronics. You can see just a set of examples here from the upper right. That is transistors, fully printed plastic transistors. You can see flexible batteries, temperature sensors. To go into the left, hybrid electronics, where you integrate silicon with plastic to get higher performance type devices. So leveraging this, in addition, at Xerox, just a couple months ago, earlier this year, we launched smart labels where you embed intelligence in a label, like you can see on wine here, to authenticate the product and to track it through the life cycle. Next year, we'll be launching some other sensors that are printed on labels that you can then envision being on pharmaceutical packaging or other groceries, etc., to again be able to build smarts into these everyday products or consumables. And so applying the technology of printed electronics, PARC also partnered. We also, in what we do, always look out at who are the best in the world in their area. So we partnered with NASA Ames Research Center for their carbon nanotube expertise in order to use it as a physical sensing particles or materials. And we partnered with BP for their commercial expertise on this project. And of course with Xerox to actually do the production of the labels. And so starting from the basic sensing materials, you print it in these smart sensors, you put them on a pole on larger areas with sensing and antennas, you put them on poles, and then you put them around a gas well. So I'm next going to let you listen to our key principal investigator, the key researcher, who's running the project at PARC, and he will be able to illustrate with a little bit more visuals of what this project is all about and the impact it can make.
I'm David Schwartz, the principal investigator on PARC's ARPA-E Monitor project. PARC's research staff are motivated by the climate challenges we face today. Fugitive methane leaks are a major environmental and safety problem requiring innovative technology to successfully overcome this challenge. We are able to leverage our capabilities in printed electronics, electrochemistry, signal processing, computational fluid dynamics, and machine learning, combined with Xerox's print manufacturing, to develop a disruptive solution to this problem. With a combination of printed carbon nanotube sensor elements, we aim to detect not only methane, but other components of natural gas, and distinguish them from interference that may be present at the well site. Carbon nanotubes have excellent properties as printed electrochemical sensors. They operate at room temperature, are extremely sensitive, are easily chemically modified, and can be dispersed in a solvent for solution processing. When a gas molecule is adsorbed onto the surface of a nanotube, a small amount of charge is transferred, changing its electronic state and therefore its conductivity. By modifying the carbon nanotube surface, for example with coatings, chemical functionalizations, or the addition of metal nanoparticles, we can change its sensitivity to different gases. By applying sophisticated data analysis techniques to an array of such sensors, we can measure a multitude of gas species. In addition to detecting leaks, the monitor program aspires to locate them to within 1 meter and to quantify their rate. This requires an understanding of gas plume dispersion under real-world weather conditions and a means of estimating leak properties in a computationally tractable way. Our capabilities in computational fluid dynamics and model-based machine learning enable us to address this challenge. Distributed gas sensing is important for reducing methane emissions, as well as improving industrial and residential safety, monitoring indoor air quality, and optimizing building operations for energy savings.
And in fact, the team is on track to exceed the cost targets, meaning significantly lower approach And so you can envision if you have these environmental sensors that could be everywhere, not only to sense gas leaks, but sense other properties, as well as these flexible electronics can be used to sense vital signs or sense all kind of in all kind of applications, they will be able to be used. So ubiquitous smart sensors will really be all around us, such that not only similar to Googling information today, we will be able to Google reality. I will be able to Google, for example, my mother's vital signs in Belgium remotely from wherever I am in the world. So you can really ultimately, that's just one example, Google reality, which will ultimately give us greater control over our lives. So the next big challenge that exists is, of course, with regard to battery life. Batteries, having distributed battery capability and reliable batteries are extremely important to achieve the vision of democratization of energy. One of the challenges, for example, with lithium-ion batteries is they're twofold. Number one is the range anxiety that the drivers has, right? You can only drive so far today because the battery can be used over its full extended operating range. And number two, although it's not, luckily it doesn't happen all the time, but there are these events of a thermal runaway, it's called, that then the battery can catch fire, whether it's in cars, in airplanes, or in the hoverboards that are now so popular. There are many that are catching fire. And so the ARPA-E again, the Department of Energy, recognized that if only we could create, or there did exist, a much better battery management system where you can very early sense, for example, that a potential runaway can happen, and then you can, through feedback loops, be able to better manage your battery. And if you can do that, you will actually be able to use more of the cycle, the actual cycle of the battery, and you can increase the range of how far the car can go, or it can reduce the weight of the battery. So the challenge that ARPA-E set out for us and for others is, again, to reduce cost and weight very significantly. And just as in the previous example, there are really the most brilliant people in multiple institutions working on solving these very difficult problems. So at PARC, we leveraged, again, our many decades of capabilities in optics. Optics, as you might know, is at the core of laser printing. So we, very early on, many decades ago, we had clear and very strong optical capabilities. Well, the same research group is now working, applying these capabilities to go with an optical fiber that has Bragg sensors, graded sensors embedded within it, to be able to have the fiber go into the lithium-ion cell itself and measure temperature inside, which is often very different than the current sensors today, which are on the outsides of a battery. So if you can only go inside, you would much more accurately be able to control the battery operation. And so here we partnered with LG Chem, who are actually the manufacturers of batteries, because we need to get these fibers inside the battery, as well as with GM as, again, an expert in the end user market. And I'm going, and then of course you put these lithium-ion cells together, and we are also working on the control system, leveraging some of our machine learning algorithms and other excellence in computer science and systems to then make sure the battery can indeed live over a full range of its operating capabilities. Let me again turn it over to one of the researchers that will show you more about the technology.
I'm Ajay Raghavan, the principal investigator on the sensor project under the AMP program. Our project drew its inspiration from PARC's multidisciplinary research portfolio in prognostics, batteries, and optoelectronics. A critical area in particular for our ideation was PARC's low-cost, compact optical sensing prototype that monitors wavelength shifts of light with as much as 50 femtometers of resolution using customized optical filters. We recognized its significant potential for dramatically reducing the cost and size of fiber optic sensing, and were exploring applications when we came across ARPA-E's AMP call. Being able to directly sense cell state internally would enable management systems to safely extract more power and capacity than possible today with electrical sensors. Still, several challenges had to be overcome. For example, we worked with LG Chem to embed the fibers into commercial XCV cells.
In the end, the fiber, the cool thing about this technology is not only is the fiber the sensor to measure the environmental properties, it's also the communication channel. So the data goes through the fiber to the processing unit that then needs to take action. And so you can envision not only these kind of technologies to be embedded in batteries, but they could be embedded in our total infrastructure, in bridges, in airplanes, in boats. So you can, in homes, of course, buildings, to create our environment and make it much more reliable and secure. Finally, the last project I will share with you is related to another big problem. And we actually heard from one of the speakers earlier, more and more people are moving to urban environments. And as cities become more congested, a lot of course, time and money is wasted, but also has a lot of negative impact to the environment. And so ARPA-E, again, the Department of Energy put a challenge forward that said, how can you create an app, it's an app and a system, it's a software system, that if 10% of the citizens use this app, the overall energy footprint that's used in commuting through the city will go down by 12%. And so to really have at the personalized individual level, to really make sure that the commuting becomes greener. And so again, many really prestigious places are working hard on solving this difficult challenge. At Xerox, PARC was able to leverage a Xerox solution, urban mobility solution we just recently launched, also earlier this year. The first city to launch it was Los Angeles. It's an urban mobility, it's a hyperlocal urban mobility solution where we give a citizen, if she wants to go from her home to her work, for example, access and insights not only in public transportation, but also in private transportation, bikes, cars, walking, public, train, buses, semi-private like lifts, company vans, whatever the hyper-local transportation capabilities are that a city has, we link with them into the app, and then you can actually look and choose. The app learns who you are. You can go sooner, cheaper, and even greener option if you prefer to take that. And then, of course, the cities get a dashboard that understands how the flow of citizens is flowing through the city and can make minor adjustments to their infrastructure, for example, add a bike share station or increase the bus frequency. So what the PARC project does has three elements. Number one, it looks at the multi-traveler optimization system. So there's a lot of computer science behind this. We partner with Virginia Tech on some of the transportation models. So looking at multiple people traveling at the same time and how can we encourage them to take different ways, for example, or sharing a car. As well as it leverages our ethnographic expertise on how to internally incentivize users to take the more green option by really learning who you are and what really incentivizes you, send you messages. And then finally, during the execution, there could be additional recommendations of making changes throughout your trip. I'm going to show one more video, if it works, showing, again, the researchers talking about how this app and the system we are working on will work.
Hi, my name is Christian Fritz. I'm the principal investigator of PARC's ARPA-E TRANSNET project. Our goal is to offer urban travelers proactive, personalized suggestions on how to travel in a way that increases the energy efficiency of the entire system without negatively impacting their own perceived quality of service. The target for the first phase of the project is to show that it is possible to reduce energy used for personal travel across the city of Los Angeles by 12%, with active participation by just 10% of all travelers. To accomplish this ambitious goal, we have assembled a multidisciplinary team of experts in artificial intelligence, cognitive psychology, and traffic simulation. Together, we will extend the Xerox Mobility Marketplace to not only provide convenience to users, but also help cities reduce energy consumption. By creating a high-fidelity model of traveler needs and their preferences and cognitive processes as they make decisions regarding transportation, we believe we will be able to devise a trip planner that proactively suggests new itineraries that are both convenient and energy efficient. These savings will come from matching people into ride pools, shifting to multimodal itineraries, optimizing route and departure times, and providing real-time feedback for eco-driving. This high-fidelity user model will be combined with a highly scalable, multimodal trip planner to build a novel decision-theoretic trip planner that explicitly optimizes for the expected energy savings. The statistical expectations will be based on the probability of users adopting a suggested itinerary in a specific context as predicted by the user model.
That would be nice, eh?
To measure the impact of these influencing strategies, we will work with the Virginia Tech Transportation Institute to build a full-fledged micro-simulation of multimodal travel in Los Angeles, including simulations of human behavior and decision-making. If successful, we will integrate the technology into the Xerox Mobility Marketplace to enable Xerox's city customers around the world to reduce energy consumption and congestion.
It's really also a fascinating approach and way of really influencing individuals to take different actions. And the same, not only is this going to be valuable at the in the energy space, when you really want to democratize energy, you want to be able to make sure individuals and companies have the information at the fingertips to make different decisions. It will impact all elements of our life, our healthcare, our financial sector, etc. So bringing this all together, coming back to PARC, one of the reasons we can really continue to innovate and how we innovate in all these multiple areas is we have really three elements to our innovation model. Number one is we have multidisciplinary research teams, right? There's material scientists with computer scientists and the whole spectrum in between that work together to understand and help solve the difficult problem. Number two, we have ethnographic experts that go in and live in the cities, seeing how people park, for example, or commute, or in the hospitals, looking how nurses provide care. So really having the end user of your technology and truly deeply caring and understanding their pain points and dreams is important. And number four, more importantly, we make sure that there is a holistic business model and all the right parties are involved from the very beginning to make sure that if the technology and when the technology works, it also becomes commercially successful. So what we do from an investment point of view is we start with internal R&D to seed fund new projects. Then we work with public sector sponsors like the ones that I showed today. A lot of the government-funded programs are higher risk, higher time frame. They're willing. Our government continues to be willing to make these bets, which is really important. Next is the innovation, the eco-partners, all the partners in the innovation ecosystem across the value chain to make sure you have all elements, all parties in place to bring this invention into a true innovation. And finally, we work with many market-facing clients today to then make sure it's a success. I'm just going to let the animation run here so you can show some of the parties and partners we're working with just in the energy space. So if you are in the energy space or any other space, please join us. We would love to be co-innovators with you. And so, again, Scott is with us today, Scott Elrod, as well as Rob McHenry, two of our senior leaders at the Palo Alto Research Lab. And if you have a big problem to solve or want to collaborate in this democratization of energy, that would be really fantastic. And I want to thank all of the amazing researchers at PARC that have made the projects that you saw here today a possibility. Thank you very much.